In this lesson, we will examine the fixed engine fire extinguishing systems that are used on aircraft. The designated fire zones for the engines and the auxiliary power unit, or APU, have fixed fire extinguishing systems fitted. The cargo or baggage compartments and wheel wells may also have fixed systems. In the event of a fire extinguishant can be sprayed into the fire zone by a fixed fire extinguisher or extinguishers. A fixed fire extinguishing system normally comprises fire bottles, filled with a fire extinguishing agent under pressure, connected via piping to the fire zones. It is an EASA regulatory requirement that a single discharge, or shot, will provide an agent concentration capable of extinguishing a fire in that zone and of minimizing the probability of reignition. For aeroplane engines, 2 discharges or shots must be provided, each of which produces adequate agent concentration to extinguish an engine fire. This requirement may be covered by having 2 fire bottles per engine, or in some systems by having 2 bottles, both of which can be discharged into either one of 2 engines. A means of discharging the fire bottle is provided on the flight deck. The discharge system is only armed after the fire switch has been operated to shut down the engine and shut off any flammable fluid. In this example, the squib lights come on in the extinguisher push buttons when the fire switch is operated, to indicate that the buttons are now armed. There is an electrically operated explosive cartridge, known as a squib, situated between the base of the fire bottle and the piping. Operating the fire extinguisher button fires the cartridge, allowing fire extinguishant, under pressure, to enter the engine nacelle fire zone. The subsequent reduction in bottle pressure operates a low-pressure electrical switch, which illuminates the discharge caption in the bottle selector. Each fire bottle may have a bottle pressure gauge. However, this may not be visible externally, and panel access may be required. If the pressure inside a fire bottle becomes excessive, due to it being exposed to a high temperature, its contents will be discharged overboard through a thermal discharge port, before the pressure becomes such that the bottle explodes. In this circumstance, the bottle pressure gauge will read 0. On some aircraft, where the bottle pressure gauges are not readily visible to the crew on an external inspection, indicator discs connected to the thermal discharge pipes are fitted externally in a position where they are easily visible. These may take the form of a green disc, which will be ejected by the thermal discharge pressure, allowing a red disc below it to show, or a red disc, the absence of which indicates a thermal discharge. On aircraft with a pressure-operated flight deck discharge light, this will be illuminated. All aircraft will have an engine fire checklist, which must be carried out in the event of an engine fire. It is important that this checklist is carried out in a controlled manner, and that all actions are completed in the correct order. A typical engine fire checklist will contain the following items. The first step will usually be to cancel the oral warning. On some aircraft, the oral warning can be silenced by pressing a bell cancel button. On others, operating the fire switch silences the oral warning. The next step will be to shut off the fuel to the engine. This is done by closing the engine high-pressure fuel valve. In the typical system shown here, closing the engine master switch performs this function. Next, bleed air, electrics, hydraulics, and engine de-icing are shut off. On modern aircraft, all of these actions are usually achieved by operating a fire switch or handle. Operation of the switch will also close the low-pressure fuel valve. Operation of the fire switch will also arm the fire extinguisher discharge switches. The first fire bottle is then discharged into the engine fire zones. If the fire has not gone out after a specified period of time, the second fire bottle is discharged. Bear in mind that this is only a generalization, and it is important that you carry out the engine fire checklist for your particular aircraft exactly as it is laid down. That is the end of the lesson. In this lesson, you have learned that each engine must have 2 fire extinguishers, each of which is capable of extinguishing an engine fire. This can be achieved by having 2 fire bottles per engine, or by having 2 fire bottles shared by 2 engines, with both bottles being able to be discharged into either engine. You have seen that when an engine fire handle is pulled, or the fire switch is pushed, it will shut off electrics, hydraulics and bleed air, and close the low-pressure valve in the engine fuel system. It will also arm the fire extinguishing system.